Hey guys, this video shows the basic processing of ICs that I do at this point, up to before I start the wet chemistry. I recorded this a while ago and felt that it was becoming a bit too long. I was planning on redoing it, but I had a subscriber next door who was having some issues with processing his ICs, so I thought it would be worth uploading it at this point. It's still a bit incomplete in parts, but it shows the basic process pretty clearly. Hope this helps you, Nick.
Hey guys, so I've had a quick look and it is about a year since I released my first full process type gold recovery video, and I have been turning out a few grams of gold every week for the past year, and my process has changed significantly along the way, but I see quite a lot of people still doing things in a way that I feel is relatively inefficient. And so I thought it's probably about time for an updated video of the full process, so that I'm basically just showing what I'm doing now, which I believe is the most efficient way to process particularly ICs. So for this example video, what we're going to use is 1 kilogram of flat pack ICs with legs. So there's no BGA chips in here, and I think I would just want to address two things that are going to come up in the comments almost irrespective of whether I address them or not. The first one is that we're not going to get very much gold out of this bucket of 1 kilogram of ICs here, considering the amount of time and chemicals that I put into it. And yeah, that's absolutely correct. If I were to process this bucket here, which is the tops only from like Northbridge, so BGA chips like Northbridge chips, then I would get for the same weight going in, I would get 10 times more gold out of this, and it would actually be a lot less work. The reason that I'm going to use these chips is actually because they are more work, because they have the legs and actually more bulk involved in them. They end up being probably the most difficult type of chip to process. If you can master these ones, then actually getting your full recovery from these is very easy. So that's the first one. So yes, I know that I'm going to put a lot more time into this and a lot more chemicals than the value of gold I'm going to get out of it, but that is just how an example video goes. The second thing I'll address up front is that a lot of what I'm going to show is not the accepted way of doing things. You'll notice as you go through, you're going to be very tempted to comment that I'm doing something wrong. I would suggest you hold off and we just see what the yield looks like, and then maybe re-evaluate what is wrong and what is right. So yeah, that's basically going to be the gist of this video. So the 1 kilogram of these kind of thicker types of 4-sided chips, so they've got pins on all 4 sides. What kind of yield am I expecting? Normally, if I'm working with ICs with legs, I like to see at least 1 gram per kilogram. That doesn't sound very much, and I think in this case even that's going to be pushing things, because it's got quite a lot of these type of chips which have a big copper heatsink built into the top, and I can actually feel the weight of that compared to one that doesn't have it, and there's a big weight difference. So the yield is not going to be fantastic, but I'm still going to be aiming for 1 gram per kilogram. The reason why the yield on these is not as good as you expect is really just down to the thickness. They have the same number of legs and the same number of bond wires as, for instance, a chip like this from a hard drive board, but if you look at it side on, this chip is 4 or 5 times thicker than the chip from the hard drive board, which would also explain to you why hard drive boards are so valuable. It's really because by weight they perform really well, they yield very well, and the reason for that is partially because the chips do not have any excess height to them that they don't need, so you're paying for less epoxy and more gold. Okay, so let's get this process underway. So I call this the hybrid process because it is a mixture of a few different processes that I've tried, and I've basically combined the best of all the different processes. And the first step in the hybrid process, whether you're doing it with ICs with legs or black tops from BGAs or just regular BGAs that still have the solder balls on the bottom, I don't actually treat it with hydrochloric acid to start with to get rid of the tin anymore. That kind of gets dealt with a bit later on in the process. So you take them straight as they come off the boards, and the very first step is going to be pyralization. So what I have here is just an empty paint can. I like to use empty paint cans for this because I find that they hold up very well in with the type of fire that I use for the pyralization. But you can basically use any sealed metal container, will be fine. So I'm going to be putting 5 or 6 5mm or so holes into the top, load the chips in, and then I'll show you how we're going to pyralize them in the next step. Okay guys, so this is the viralization setup that I tend to use these days. So I've got an LPG bottle here, long bit of hose, and then I've got the same LPG burner that I used in my trommel depopulator for the RAM. And I have tried charcoal and I've tried wood, and really spending the time once and building an LPG burner will save you a lot of time in the long run, because you can basically get this thing going, go and make a cup of tea, come back in half an hour and see how it's going. It basically takes care of itself. Then I have got a little drum like this, and I haven't built a proper furnace yet, but that's definitely going to come soon. But as you can see, I've got our ICs inside the paint can there. I've got the burner pointing at it, and I'm just going to put a lid on this to keep the heat in as much as possible. That just gets things going a bit quicker and saves a bit of gas. So yeah, basically I've got 5 or 6 holes in the top there, and this is probably a good time to talk about what we're trying to achieve here. So there are 2 words that matter in this kind of stuff. There is pyrolysis or pyralization, and there is incineration. What we are going to do here is called pyralization or pyrolysis, because we are going to heat the chips inside the can to basically their burning point. But because there is no oxygen inside the can, it means that the plastic is not really burning. It's better to think of it as degassing, and the gases come out and they shoot out from the little holes and they get burnt up. And as you will see, contrary to normally burning plastic, there is very, very, very little smoke. And you know, it's a relatively clean process as far as dirty processes go. It is not the worst way to do this. Incineration then, on the other hand, is of course burning with oxygen. But we will actually not be doing incineration today. We are only going to take this as far as pyralization, and then we'll talk about what the next step is and what the implications are of not having done the incineration. So yeah, I'm going to just get the top on. Obviously for this I've got a MAP gas canister just to get the whole thing set alight. I like to use some welding gloves, obviously just to protect your hands from anything hot, and also I've got a couple of these shifting pliers to just hold on to things and move them around if I need to. So yeah, obviously try to do this in the safest possible way. Don't hurt yourself or anyone else. And yeah, last thing here, as you can see, I've just got a couple of rocks sitting around the burner, just because we've got a little bit of wind today and I don't want to affect the flame too much. Building your own burner, Grant Thompson, King of Random, has an excellent video about how to construct a burner, and what he's got at the end of it, spoiler alert, is that the secret to making these things work is to be able to control the airflow into it. So I've got an adjustable regulator on the LPG, but I've also got these little wings on the side that I can turn to adjust the airflow. Okay, I'll get this going and be back with you guys shortly. Okay guys, so it looks like we're pretty much there after 45 minutes. I can't see any more yellow flames in there. As you will see, we have got no flames at all coming out the backside. So yep, that's pretty much ready to go. So probably about 45 minutes or so. Hey guys, okay, so these chips have cooled down now, and as you can see they've been well pyralized. And really the only reason that we've pyralized them is to make the ball milling process a little bit faster. You'll see very easy to break by hand, so even like all of these, they just crush up like nothing. And I know that there is going to be quite a lot of confusion at this point about why I'm not incinerating these to get them white, even though the common belief is that that's the way to do it. But we're pretty much going to deal with the carbon later on. At this point, as I said, the only reason to incinerate or to pyrolyze was to make the crushing go faster. So what I'm going to do now is put them in my little ball mill in the corner of the workshop here, just like that. These tins are a handy size because they fit 1 kilogram of chips, and they also fit inside the mouth of the ball mill. So just try and get everything out of there. That should be relatively clean. Sometimes some of the chips can get stuck, like there's one little one stuck in there, so I'll take care of that in a minute. But yeah, that's pretty much the next step. So I use this little ball mill that I made and documented quite a long time ago. The only upgrade really has been that I had some trouble with the geared motors, and so I've gone up to a fairly large size stepper motor that I drive for a little circuit that I built, and same kind of belt drive as before. I've got the big ball, so it's just a single ball, so it's not really a ball mill, it's more of a crushing type mill. And as the thing drives around, the ball basically gets lifted up and dropped on the chips, so it crushes them up. Now we're going to initially just run this for about a day or so, and then I'm going to get rid of any of the heat spreaders and really big parts that are in there, and then run it for another day or so to really make the material very fine. Getting rid of the heat spreaders after the first day or so helps a lot in terms of you don't really want those heat spreaders to take the impact. You want the impact to be taken by the material that you're actually trying to crush. Hey guys, okay, so I've had those 1 kilogram of chips running about 24 hours in the little ball mill here, so they should be now relatively crushed already. And what I usually do after the first day or so is I just use my coarsest sieve, and this one has fairly big holes, probably about 2 millimeters or so for the squares. And all I want to do at first is to go through all of this material and only remove the biggest bits of copper and steel, things like heat spreaders or very big legs, stuff like that. We want to try very hard not to catch anything else in this. So what I'll quickly do is I'll just go through and sieve all the contents of this, and then I will show you guys the stuff that we are going to discard at this point. You'll be able to see from the look of it that we won't be losing any bond wires at this stage. Okay, I'll get that done and I'll be back with you in a few minutes. Okay, so here we have the reject stuff from the first set of filtering. So you can see there's some very big copper heat spreaders, quite a few of those, and that's basically the reason why you get lower yield with some ICs, is those copper heat spreaders can be very heavy relative to the weight of the epoxy and the gold. There's a few black bits in here, but don't be concerned. I've checked through them and they're all basically metal. There's no epoxy left on any of those, so that's not a concern. And you'll see we've also immediately got rid of quite a lot of the bigger, fatter copper legs from ICs, so there's a few of those in there. But yeah, basically I've got that powder back in the ball mill, so another day or so and we'll be ready for the next process. Hey guys, okay, so I've got the powder here that has now had after our first set of sieving with the very coarse sieve, that's had another day in the ball mill to just get it really super fine, and we're now at that point where this stuff is kind of talcum powder consistency. You'll see it doesn't have grains, it flows when I shake the plastic, so that's really good. That's where we want this to be at for now. Now we're going to go through another set of sieving, and I'm actually going to sieve this stuff 3 times now, not with the coarse sieve but with the kind of fine flour sieve. So you can see might be able to see the difference there. Anyway, this is your super coarse kind of kitchen sieve. This is a fine flour sieve, also for kitchen use, which is essentially about twice the whole size, I would say, of this one, which is a 60 mesh sieve. So you can use that as a rough guide. We'll get to the 60 mesh sieve later, but for now we're going to use the medium sieve. And what I'm going to do is sieve this stuff 3 times through the sieve, and what you will notice happens is you're going to get rid of quite a lot of the metal legs. Before we get into washing of the powder, we want to get rid of as many of those metal legs as possible to make washing of the powder easier. So I'll quickly run through that. It's only going to take 10 minutes. Once again, dust mask is highly recommended. Just this stuff will go everywhere, so keep it out of your lungs. Hey guys, so after about 10-15 minutes maybe of sieving this material 3 times through the medium sieve, this is the result here. So we've gotten rid of quite a lot of the metal legs from the ICs. Obviously I'll be checking this with the microscope for bond wires, but in my experience I'll find 1, maybe 2 bond wires in all of this, and considering we've got tens of thousands of bond wires in here, it is not much of a problem. Okay guys, so what I'm going to do next, after we just finished sieving that material in there, is we're going to have to wash it. And the washing of this material, especially this first stage of washing, usually done with a couple of buckets, is absolutely the most crucial part in the whole process in terms of getting it right and not losing gold. If you do the old method that I showed about a year ago, where you use 2 buckets and basically go from one bucket to the next bucket, you will get it pretty good, but every so often you'll get a low result and you won't really know why, and the result will be because of your washing. The bond wires are so small that if you're a little bit vigorous with your washing, you will lose bond wires. So this is the process after many different things that I've tried that works and is relatively foolproof. So we've got here about a 20-liter bucket, just a nice big is good for your initial wash bucket, and down the bottom here, about maybe 2 inches up from the bottom of the bucket, I've got this T-shaped hose with a tap connected to the end of it. That goes into one of these square gold pans, but you could also just as easily use a mini sluice type setup for this, and that goes into the discard container down the bottom. And the idea is we're going to put the dry powder into the bucket. I'm going to give it a generous helping of dishwashing liquid. The question will come up whether you want to use dishwashing liquid or just a surfactant like a rinse aid for a dishwasher. I have tried both, and I believe even with the hassles of the bubbles and things, the dishwashing liquid does actually do a better job of literally washing the powder. Going to need something to mix with. I just have a little bit of plastic tubing. So yeah, basically pour the powder in, give it a good squirt of dishwashing liquid, fill the bucket right up to the top with water. So you want to use quite a bit of water, especially on the initial wash. I'm going to give it a stir, make sure that all of the powder is completely wetted, so there's no dry floating powder left. And then very important, I'm going to set my stopwatch, and especially for the first wash I'm going to leave it for 30 minutes to settle. The second wash I'm going to leave for 20 minutes, the third wash I'm going to leave for 10 minutes, the fourth wash I'm going to leave for 5 minutes, and then there I'll go progressively lower until the water coming out is not as clear, is not black anymore, or is relatively close to clear. Having a good washing system here means that we never had to incinerate these chips to completely white. They are very black, but they are also, the carbon is also incredibly fine at this point, and it's very easy using a washing system like this to remove that very fine carbon. This is the first stage of washing, so I will just get this underway and I'll show you guys the result that end up in this pan here, even with a nice controlled release of this. And you'll be able to see if I'm catching little bits of copper in this pan, that means that when you poured one bucket into the other bucket with the old method, you were definitely losing some bond wires in there. Okay, I'll get this going and be back with you guys in 30 minutes or so. Okay guys, so 30 minutes or so has passed, and as you can see there's a small leak in my tap, which means that this is filled up a little bit, but no big deal. I'm also dodging a bit of the rain, as you guys can see. But what I'm going to do now is I'm just going to open this tap a little bit, see if I can do this one-handed. Get a bit of water flow, so nice black water. So we're washing out all of that carbon from the chips. 30 minutes is more than enough for the bond wires and anything heavy to settle in there, and because we are so far off of the bottom, we're not likely to be sucking any of those bond wires across. There usually does end up a few bond wires or copper wires in here, the reason being that I think as you're stirring the inside, some of them will go and settle in this tube. But we have this little mini sluice basically as our backup in case we have any of those problems. We can also just, so I tend to try and reposition this, and then I tend to try and increase the flow just a little bit at a time until I get a nice even flow across the front here. So I might give that a little bit more, and what that does, so that's starting to look pretty good. What that does is it just tends to do a good job of washing away the carbon, but it's still going to trap anything else in the little grooves there. Okay guys, so I'm on the last wash here. This is wash number 4, and as you will see, the water coming out is relatively clean. This is after 5 minutes of settling in the bucket. So the reason we have just gone through this bucket washing process is only just to get rid of the very light, very fine carbon material. We really don't want to lose anything else at this point of the bucket washing. There is still lots of silicon, and all of the metals should still be in that bucket. The reason for this washing is to make the next steps go a little bit smoother. So the next step first is I'm going to transfer that material to a stainless steel pan, and I'm going to dry it just on a heating element or on a gas flame. So basically just dry out all of that material, and then we are going to sieve it with that 60 mesh sieve. So we're going to get rid of whatever is left of any component legs, and then we're going to do the magnetic separation. So I'll be back with you guys soon and just show you how that's going. Okay guys, so the basic process for getting this powder dried is shown here. So this has been through the bucket washing process, and the next stage is we want to get rid of any remaining copper and iron parts, so copper legs and any magnetic parts. And to do that effectively, we have to dry the powder first after the washing process. So yeah, just basically I find the easiest way is just a stainless steel pot, even though this does not look stainless steel anymore. It's done quite a lot of this, as well as and just on a barbecue like this does a pretty good job. It'll basically just keep going like this until it is completely 100% powder again and completely bone dry. And yeah, don't worry about any fumes or any smoke or anything from this, because we've already pyrolyzed everything. There is zero smoke. You're not able to melt anything more in here, just with the temperature that the barbecue will get. So basically, just yeah, it takes 10 or 15 minutes or so. Just let it dry out, and I'll be back once this is dried for the next part of the process. Okay, guys, so we are nearing the end of the drying process of the powder here, and the only thing that I really wanted to pull your attention to at this point is you will notice the color has now gone to a kind of dark gray color rather than a black color. This is a very good indication that we've already got rid of a dramatic amount of the carbon from this, because remember, we're wanting to get rid of the carbon anyway, because we didn't fully incinerate those ICs. And so the fact that we're now going, and the more I process this, the more it's going to get grey and not black. But you can see already just by that initial bucket washing, we have reduced the bulk of it dramatically, and we are now turning more grey rather than black. Okay, I'm just going to finish this drying. It's probably got a few more minutes to go, and then we'll do the next process. Okay, so you guys are probably getting a little bit tired of me sieving stuff at this point, but unfortunately that's the next step again. So we've got the powder here that I've just dried on the barbecue, and it's completely bone dry, very powdery. But the nice thing is, once you've done the first bucket wash, it no longer creates a lot of dust that goes everywhere. So it's actually quite easy to work with. It's not very dusty. It's quite, everything that's left is relatively heavy. The final lot of sieving, we're going to use a 60 mesh sieve for. Some people would go up to 100 mesh, but I found that I lose too many bond wires going to 100 mesh. So what I'll do is I'll sieve all this material through once, and I'll put the reject material in there, and then I'll quickly show you in the microscope what the reject material looks like. Usually on the first pass of the reject material, I'll be able to show you a few bond wires, and then what I do is I put the reject material back through the sieve, and usually I can get pretty much all the bond wires. Okay, so the next step after putting all this material through the 60 mesh sieve is we're going to put it down the vertical magnetic separator to remove any remaining iron based components from this powder. And I've shown this in previous videos, so I'm not going to go through too much detail, but essentially I've just got a piece of plastic pipe just clamped to the bench, completely vertical, and then I've got some hard drive magnets on this side spaced every so often, and essentially the powder goes in the top. The idea is that the powder in free fall does not tend to cling together, which means that if the iron parts get drawn to the magnets and stay inside the pipe, the everything else should just drop through to the bottom where most of our gold will be. We can have a quick look after this just through the microscope again and see if we can find any bond wires in the iron stuff that got caught. There's a decent chance that there might be a few, so we'll have a quick look. But yeah, I'll just get that done and be back soon. Okay guys, so after we finish the magnetic separation, the next step, this is going to look a bit deja vu, is going to be to rehydrate this powder solution using a little bit of rinse aid from a dishwasher, just to make sure that all of the powder is nice and wet. And then we are going to run this all through the blue bowl system as shown here. So this is just the regular off-the-shelf $100 and something blue bowl, which works very well. There's really very little you can do to improve on the real thing here. And I've got a 2-bucket kind of, or 3-bucket system really here. I've got my reservoir of clean fresh water there, and then that goes through the blue bowl, goes into the main secondary bucket here, which has little holes about halfway up, which then empty into the main bucket, which then gets discharged from there. And really the key with this, obviously one thing is keep it nice and level, so I keep on checking the level as I go. The other thing is to so keep it nice and level, and then the other thing is just in terms of the rate that you feed it and how you make it work. So I tend to feed it about 1 to 2 tablespoons like this of material at a time, depending on how the process is running in the bowl. and you want to be quite, like, running of the bowl is something that's going to take some experience. I can tell you as much of the detail as I want, but you really have to try it a few times until you get a feel for it. Obviously the material here has all now gone through a 60 mesh sieve. Some people even recommend going to a 100 mesh sieve for optimum performance of the blue bowl. When you are separating by density, it works much better if the particles are all roughly the same size and same shape that you're trying to separate with. So we've done the best we can with this powder. So I'll get this process started, and I might do a little bit of video through the middle of the process to show you what's happening. But yeah, I'll be back shortly. The other thing is, after every, say, 4 or so spoons of material that you process, I tend to stop the blue bowl and wash the remaining material into a nice clean glass container. So hey guys, okay, so I've just finished about an hour and a half or so in the blue bowl, and I've got here the beaker of material that is from the first run of that IC powder, and then I've taken everything that made it through the first run and run it again, just so we can see here how big your losses are from number 1 to number 2. So I'll get these under the microscope and we'll have a quick look at them. Okay, so here we have the first beaker, which has the main run, and as you could see when I'm zoomed out, not very obvious that there's much in there. If I go to full zoom though, and I get the focus in a little bit, you'll see pretty clearly bond wires relatively everywhere. Now we are just looking at the top of the stuff that's in there, so I expect many more bond wires will have settled lower to the bottom, but you can quite clearly see we're dealing with quite a large number of bond wires. It doesn't really matter where I go. If I go somewhere and focus like there, we will see some bond wires, so that's quite encouraging. That means for what we may have lost so far, we still have quite a lot of bond wires actually in there. So that's quite nice. Once again, this gives you a good idea of just how small they are. So if I get rid of that beaker, and in its place we put the beaker with the second run material. Let's have a quick look through what we can see here. So there's not immediately very many bond wires compared to the one we just looked at before. You just get the focus in a little bit for you guys. I'll just see, I'm pretty sure we will find some in here. So let me just keep looking. Let's look around this area here. Yeah, so there's one there. Just get the focus right, should be about there-ish. And you guys can see that bond wire there, roughly, yep, that one there, roughly in the center of your screen. We'll look around a little bit more. So there's another little one there, pretty much in the center of your screen. A little bit hard to see, but it's a little bit clearer for me looking through the eyepiece. I can see those quite clearly. Let's look some more. There's another one there. So as you can see, these are quite short, these little bond wires, and but yeah, they definitely well worth running the blue bowl material twice. I think you might get about 1% or so of them caught up the first time round, or lose them the first time round. So definitely worth running it a second time just to see what you get. Okay, let's carry on with the process here.